All right, so we're going to do questions here on the homework from 3.2. And we're going to come up with a logistic function that has these characteristics. And the generic logistic we're going to use is f of x equals c over 1 plus a e to the negative kx, which is the discovering logistics we studied on that one sheet when we first introduced it. The book has another form, I'll just call it B, and they say c over 1 plus a times b to the negative x, something like that, right? I prefer to use this one, so I'm going to use this one if that's all right with you. Okay, so they told us the initial value is 10. So what does that mean? Initial means, right, is 10. The limit to growth, that's another word for the carrying capacity, is what? 40. So that means C equals 40. And it passes through the point 1, 0. So these are the characteristics of the function that we have to use. So looking at our information, we know that we can already fill in C. All right, so I'm going to suggest to you that this is y equals 40 over 1 plus a e to the negative kx. And then I'm going to use the next point to help me out. What happens when we let x equals 0? Using 0, 10, this e to the 0 goes to 1. So then we can say that 10 equals 40 over 1 plus a. So we can cross multiply here. Oh, no, it's 20, isn't it? I'm sorry. No, that's right. Okay. I'm already using this point. I looked up and I saw that point. All right, so this will be 10 times, if I cross multiply 1 plus a equals 40. So we get, if I divide by 10, we get 1 plus a equals 4, a equals 3. So that's good news. So now, using the point 120, I can say that 20 equals C, which I said was 40, over 1 plus, now we said A was 3, so I can say 3e to the negative k, right? Because x is 1. All right, and so I'm going to cross multiply here and get 20 times 1 plus 3e to the negative k equals 40. I'm going to divide by 20 because that's easy to do. So this will be 1 plus 3e to the negative k equals 2. 3e to the negative k equals 1. E to the negative k equals 1 over 3. And to solve for the k, I have to take the natural log of both sides, bringing the negative k down in front. And so then we get negative k, ln of e equals the natural log of 1/3, but ln of e is 1. This goes to 1. And so we get negative k equals natural log of 1 over 3. What? You can expand this on the left, and you can say that this is the natural log of 1 minus the natural log of 3, right? Because using the properties of logs, if you divide, you are really subtracting. And the natural log of 1 is 0. And we say negative k equals negative ln of 3. Okay? Now k equals natural log of 3. All right, so now let's plug all our stuff together and we get f of x equals 40 over 1 plus 3 times e to the negative k, which is negative ln 3 times x. Now, I know your book had it written the other way, but let's see what happens here. If I go 40 over 1 plus 3e, may I say that this is the same as saying ln of 3 times negative x, is that equivalent? So what happens here? Right, but because then that would just be 3.
It's like negative 3, then that means
Yeah. Yeah. What I want to know is if you type this on your calculator, type this on the calculator for me. E to the negative ln of 3.
Just that, or the whole thing?
I just want to know what this is.
It's 1/3.
You do it.
Yeah.
This says,
no,
oh, that's it. Okay, I was looking at 0.58. Is that the next answer?
Probably.
Okay. I was looking at, in my brain, I'm going 0.58, 0.958, and the answer is not 1/3. Yeah, I'm all right with this. Okay. So this, if you want to do it algebraically, is 1 plus 3 to the e to the negative, or just ln of 1/3, right? You could say that. Times x, which is 40 over 1 plus 3 times 1/3 to the x. Except that this should be an exponential growth, so that should be. No, that's right. Okay, I'm all right with it. Everybody understand how to at least get to this point? That's easy to do. All right, 25. Initial population is 16. What are they telling me in a top secret language? 0 to 16 is the point. Maximum sustainable population. That's the carrying capacity of 128. And passing through the point 532. So this is the same process here. And so we're going to go f of x equals c over 1 plus a e to the negative kx. So what can we fill in c right away? Now, if you know the y-intercept, what does the y-intercept always equal? If you let x equals 0 here,
C over 1.
equals c over 1 plus a. So what can you do now that you know that 16 is the y-intercept? You can say 16 equals c over 1 plus a. Multiply 16 times 1 plus a has to equal c, which is, what do we have c? 128, I'm sorry, 128. So then this is 16 plus 16a equals 128. When you do that subtraction, you get 112.
12.
Is that right? Does that go evenly?
Yeah, 8.
What?
8 and 7.
7. I'm happy about that. All right, so then we can say 1 plus 7 e to the negative kx. So what's the only thing we have to solve for now? K. And I'm going to use this point here, saying 32 equals 128 over 1 plus 7 e to the negative 5k. All right, cross multiplying 32 times 1 plus 7 e to the negative 5k equals 128. And if 16 goes into 128, I suspect 32 does as well. So it says 1 plus 7 e to the negative 5k equals 4. 7 e to the negative 5k equals 3. E to the 5k. Negative 5k equals 3/7. You have to log both sides. You get negative 5k. May I take a liberty of just doing that? It's the natural log of 3/7. K K equals, negative 1/5 times the natural log of 3/7. So putting that back in my equation, I get f of x equals 128 over 1 plus 7e to the negative k.
So what?
So this is positive. So this is going to be 1/5 natural log of 3/7 times x. Now, if I wanted to see if that's equivalent to the answer in the book, I could say that this is 128 over 1 plus 7 e to the, what happens, I'm going to raise this 1/5 up. So this will be ln of 3/7 to the 1/5 times x. Okay, so I want to know, if you will, 128 over 1 plus 7. Now that's going to be these cancel here, and you're going to get,
24.
point what?
8.1.
Hopefully does that match? Yay! So are they equivalent? Yeah. I just think in your mathematical career, you're probably going to see the e to the negative kx more frequently than you will the other. So it's just good to get familiar with that format. All right, moving right along. 27. This is just doing the same thing except visually, right? I'm giving you the graph. So what do we, c equals what here? I mean, obviously we've got it, right? So y equals c over 1 plus a e to the negative kx. I'm given my initial point, which is 0.5, and c has to be 20. So it has 20 over 1 plus, and now how do I find a? We're going to say 5 has to equal c over 1 plus a, but we know c is 20. So this is 5 equals 20 over 1 plus a, cross multiplying. 5 times 1 plus a equals 20. You can divide the 5 over. 1 plus a equals 4. A equals 3. They really like 3.
I was just, I'm stuck out, I wasn't supposed to be registering or.
I don't know. E to the negative kx. I need to know what k is, so I'm going to use the point. 210. So we're going to say 10 equals 20 over 1 plus 3e to the negative kx. Or wait, negative k times 2, right? So negative k. Cross multiplying 10 times 1 plus 3e to the negative 2k equals 20. Divide by 10, and I get 2 on the right hand side. Equals 2. Move the 1 over, and I get 1. And then I'm going to get 1/3 again. E to the negative 2k equals 1/3. Maybe the people that were writing the book just had that off. So if we take the natural log of both sides, what happens here? We get negative 2k equals the natural log of 1/3. And I would just, k equals the natural log of 1/3 over 2. All right, so what's my function equal? Y equals, we said, 20 over 1 plus 3 e to the negative 1/2. Okay.
No.
Nope,
ln of 1/3 times x. You have to be positive, right? Yep. All right. So that would be our answer, except now it would be nice to know if we match the book. So we're going to figure out what this is. So that's going to be y equals 20 over 1 plus 3e. I'm going to bring the 1/2 up. So it's gonna be ln of the square root, right? Or 1/3 to the 1/2 times x. So what does that value equal if somebody does that in the calculator? You do the square root of 1/3, and you get. Yeah, I don't know how to it's 1/3 raised to the 1/3. Okay, is it root 3 over 2?
Yeah.
That's right, that makes sense now. But what's root 3 over 3 mathematically? Woo-hoo! We match, don't we?
Yeah.
Will we ever have to decide the way to look at it? Like, make the quiz?
No, I'm happy to do it that way. Could you do it if you had to?
Yeah.
Yeah, I'm happy to do it if you had to. The amount of C grams, carbon 14, is given by this expression. Estimate the half-life. How do we do half-life? Well, okay, so if it starts with 20 grams, so we're gonna say, right, now, they right here, don't they have this e to the negative something? That's not what we're used to in the formula, right? Is that what we're freaked out about? Okay, so I want you to type in your calculator right now, 20, I want you to type in e to the negative 0.00011216. Put this in. What is it? E to the negative point.
Oh, wait. Oh,
You can just,
I don't want that. We don't want. Huh.
oh, yeah, 0.999878.
Weird, isn't it? So I think it should be that. All right, well, we're gonna, the half-life needs to be at 10, right? So this is gonna be 10 equals 20 e to the negative 0.00012116t. Divide by, we get half, isn't that what you expected? E to the negative 0.00011216t. Now what? Natural log. Natural log of 1/2 equals negative 0.00011216t. So t equals negative, again. Natural log of 1/2 divided by negative 0.00011216. So t equals now, in your notes, I did this very problem with you, except what base did I use? You'll scroll back a page. Didn't I? Did we get the same answer? We absolutely did. All right, so question on that one? Number 45. The number of students infected with flu at BT High School. After 2 days is modeled by this function. It's a logistic. What is the initial number of students infected? How do we figure that out? So A is E of 0. So we do that, we get 800 over, right, so 800 over 50, which is, what? 60.
16.
60, sorry. 60, duh. People, students. There's usually teachers in that, right? Did we read the same here? All right, so part B says, when will the number of infected students be 200? How do we figure that out? So we go 200 equals 800 over 1 plus 49 e to the. Now, we could solve this graphically or we could solve this algebraically. How would you like to solve this? Okay. So to do that, we gotta get our calculator out.
You have to do this graphically.
I expected you to do both. Would you know the answer if you do it graphically?
Yes.
Right. So y equals, what's our function? 800 divided by 1 plus 49 e, which is blue, second e to the negative. Is it 0.2?
Yep.
0.2 x. Close, there it is, and I want it to equal 200. So what do you suppose my window should be? At least 800. I'm going to make it 1,000. Oh, well, 1,800 works for me. Does it work for you? I think this will work. Okay, so graph. Here's my logistic. And there is my 200. So we're going to go second, calculate the intersection point. First curve, yes. Second curve, yes. Please, yes. So this is going to be at t equals. What does that mean? Days, right? Almost 14 days, yeah. All right, part C. Well, let's do it algebraically because, yeah, I would expect you to do that. What are we going to do first? Cross multiply? Yes. How much are they solve? That's okay. So it's going to be 200 times 1 plus 49 e to the negative 0.2t. Oops. Sorry about this row parentheses there. Equals 800. Now what? Divide by 1 plus 49 e to the negative 0.2. Equals 4. 49 e to the negative 0.2t equals 3. Yeah, there it is again. E to the negative 0.2t equals 3 over 49. So I'm going to just take the liberty of taking the ln of both sides. I'm not going to show it. Are you okay with that? Negative 0.2t equals the natural log of 3 over 49. T equals the natural log of 3 over 49 divided by negative 0.2. And T equals imagine that. Equal, yes? We expect that. Part C says the school will close and 300 of the students. So what are we going to do now? Find out where it equals 300. So what do? We can do it graphically. What's the change? That's a 16.9, so about 17 days. So do you need to see me solve that algebraically, or do you get it? Let's see.
46 is like exactly the same.
Okay, so we'll, hold off on that. All right. So let's see what we got going on here.